So today we'll be touching on what we believe is a crucial component of a complete defense in depth against cross-site scripting that you all know and love. Talking a little bit about CSP, content security policy, and trusted types. So we'll specifically be talking about our approach to wide-scale adoption of these features and what we believe is a sustainable and scalable tool-based approach to bridging the gap between what we have been able to do inside of our closed ecosystem at Google and what we think should be possible for all web developers in the open source ecosystem as well. Great. So before we get started, here's a little bit of a quick background. Um, so we've all heard of cross-site scripting before, right? And we might also have heard that it is a big problem in the industry. So as you can see in this graph, this is some data that we've gotten from the bug bounty program that we've been running for many years at Google. And this is to be completely transparent, a graph from several years ago before we started doing this very systematic and scalable approach to trying to resolve cross-site scripting ecosystem-wide. You can see that turns out that we have a lot of web apps at Google. So a lot of the issues that we pay out for are indeed web issues, and a big chunk of it is cross-site scripting. So, and the takeaway from here is that this is still a serious problem for a organization like Google, where we have a lot of folks who spend a lot of time trying to think of novel and scalable solutions to tackle a class of problems like cross-site scripting. So this must be a big industry-wide problem, and it must also be quite difficult for folks to solve outside of Google without the amount of like institutional support and security engineers and folks working on tooling to help with this adoption. And to add to this problem, so we think that cross-site scripting is a thing of the past now that we don't really deal with the raw DOM APIs anymore. But this is not actually true because we still see bits of internet outrage like this. So if you can see the little code snippet that is linked here, we see that in a React component, which is supposed to be very modern and supposed to abstract away these calls to the DOM API so you don't have to get your hands dirty and deal with these potentially unsafe APIs and potentially make a mistake of writing an unsafe pattern with these APIs. Someone still managed in this very abstracted ecosystem to sneak in a call to an inner HTML assignment. So the lesson to be learned here is that there is still a disconnect between the devs who write the code and the security professionals who understand the dangers of cross-site scripting and just having fancy tools that are supposed to be taking away some of the rough edges. It does help, but it is not a guarantee that our code bases are completely free of patterns like this. And furthermore, there are some academic studies out there that show that the state-of-the-art defenses that we've been working on with trusted types adoption and with content security policy adoption is sort of difficult to adopt for end users with the documentation and tooling that's out there. And here's another one about CSP. There really is a lot of shall we say, like academic critique of the difficulty of this problem. So that really is a perplexing problem for us, right? It's clear that the developers are very confused on how to integrate what we recommend as common cross-site scripting defenses into their workflows. So what can we do about this? So here is a recap of how we see the situation. So let's take a second to point out that it's not as scary as these usability academic studies point out, right? The like trusted types and content security policy aren't completely unadoptable because we do have a proof by construction, at least inside Google, that we have managed to roll these out to hundreds of different web apps, and we do provide their security benefits to users at scale. So but it is still a valid critique that there is a lack of information as these user studies point out. And we are, I think, both here at Google, but also as a group together with Swag, trying to get that information out there and solve that problem. So can we do a bit better than that? And this is, I think, our main point here, right? So in addition to just getting the information out, we believe in a tooling-based approach to solve these more sustainably at scales in a more ergonomic way that is easier for developers to understand. So yeah, we love having this particular slide template in all of our talks, but just to talk through the big points here, um, the tooling here is an integral part of the workflow that not only enables developers to build safer code by nudging them towards patterns that are inherently safer and away from the sharper edges of these dangerous APIs, but also have this element of a bit of like advice and education built into it so that developers as they work with some of the constraints and the nudges of the tooling come away with a better understanding um, of why these APIs are dangerous, what the problem space is, and how to write code that is a little safer. And this aligns very well with what at Google we call the secure by design approach and our commitment to industry-wide influence to really further these ideas of secure by design throughout. You can click on the link to learn more about the pledge that we've signed there.